Suppose you have this following problem. Wouldn't it be nice to just say that x plus 3 equals 1, that is, the numerators are equal, take away 3 from both sides and be done? Well, it would be nice, but you can't always do this. What you need to realize is that this bottom, x plus 11, is 8 more than the top. Now, let's just suppose for a moment that we had 7 over 15. Now let's look at this very carefully. We have x plus 3 over x plus 3 plus 8. And if you notice, the bottom is 8 more than the top. It's 7 plus 8 in the bottom. That is, yes, absolutely, x plus 3 equals 7. Because if x plus 3 is 7, then the bottom is 7 plus 8, which is 15. So you can just solve x plus 3 equals 7 and conclude x is 4. So let's look at the initial problem. I have 1/3. The bottom is only 2 more than the top. And 2 times 4 is 8, which is the difference between the top and the bottom. If I multiply top and bottom by 4, I get 4 over 12. But now I can say that the top is 4 and get that x is 1, or I can say that the bottom is 12 and conclude that x is 1. Either way would work, because if you have x plus 3 over x plus 11, which I'll write this way, is equal to 4 over 4 plus 8, yes, x plus 3 is 4. Because if this is 4 and you add 8, you'll get 4 plus 8. Okay, so that's pretty nice to be able to do that. Now, it only works if I'm using linear equations. If I'm using linear equations, it only works if the slopes are the same. Like if I have 2x on the top and 2x on the bottom, and I can add any number I want. And suppose I have 2/3. Well, in our case, the bottom is 5 more than the top on the left. But on the right, it's only 1 bigger. The bottom is only 1 bigger. So I'll multiply by 5 over 5. And that gives me 10 over 15. That means this must be 10. And if I had a number that makes this equal 10, then yes, it'll make this be 15, because the bottom is 5 bigger than the top. So if I can solve for the unknown number, I'll be okay. This must be 7. So 7 plus 3 equals 8. So this is 7. X must be 7 over 2. Now, you may say, here, if I have, let's not do 2x. If you have x plus 4 over x plus 8, the bottom is 4 bigger. What if you have this is equal to 3 over 2? The top is bigger. Well, you could realize this as negative 3 over negative 2. Now that changes which one's larger. Now the bottom is larger, and I want it 4 larger. So I'll multiply by 1 as 4 over 4. And I get negative 12 over negative 8. So x plus 4 should be negative 12. Here are negative 16. If you don't know, you're at some number. Call it x. You add 4. 1, 2, 3, 4, you end up in negative 12. So what's this number? Negative 13, negative 14, negative 15, negative 16. X is negative 16. And that works. That's an answer. Okay, let's do one more, at least, where it's not so obvious what to multiply both by. And suppose you have 2 over 7. Now, on the left side, it's 3, the bottom is 3 more than the top. But over here, it's 5 more. So the question is, what do you multiply 5 by to get 3? Well, if you divide by 5, the answer is 1 so far. 5 over 5 is 1. If you want 3, multiply by 3. You should see the 5's canceling out, and 5 times 3/5 is 3. So what I'm going to do is I'm going to multiply top and bottom by 3/5. And then I will get 6 over 5 divided by 21 over 5. And just for the record, the bottom minus the top, but if the bottom's bigger, this is 15 over 5. Look at that. The bottom is 3 bigger. So now all I do is I say x plus 2 equals 6/5. X plus 2. So I would love to write 2 with the 5 on the bottom. And that's very easy to figure out. Because 5 times 2 must equal the number on top. So I'll write the 2, as 10 over 5. And this is equal to 6/5. Now when I subtract, I'll have common denominators. This cancels out. I get x equals something over 5. 6 minus 10 is negative 4. And that would be your answer. You don't need to cross multiply. Try one more like that. You have x plus 7 over x plus 3. No, I've never had a minus, or plus and a minus. So what if we have x minus 3? X minus 3, and this is equal to 13 over 5. Now, the 10 is 5 bigger. Sorry, the 10. The bottom, the top is 10 bigger than the bottom, because x plus 7 is the same as the bottom plus 10. So the bottom is 10 bigger. But over here, the top is only 8 bigger. So I need to multiply the 8 by something to get 10. Well, divide by the 8, now that's 1, and multiply by 10. Or if you prefer, 8 times what is equal to 10? Well, I don't know. 10's not on the 8 table, so I'll divide both sides by 8. And I get x is 10 over 8, which is 5/4. Just like over here, I got 10 over 8, but that's 5/4. So basically, you can just get away to save time by multiplying the top by 5/4. That is, x plus 7 must be 65 over 4. What this is. I mean, I'll denote I'm doing the same to the bottom. Okay. So I'll take away 7, but over here, I want to write 7 with the 4 in the bottom. It's really, really simple. 4 times 7 is what goes on top. It equals 28. So here, I'll take away 28 over 4. On the left side, I just get x. On the right side, I get 37 over 4. and that can't be reduced, and there's my answer. There's my answer. And on the bottom, I did my side work. I did it twice. I did it here to figure out to multiply by 5/4. And then I did it again over here on the right to figure out to multiply by 5/4. Okay, so this is a really nice way of doing it. And one last time, if I had a 3 in the front, all that will tell me is that my x is really 3x. So x would be 37. Divide the right side by 3. You get 37/12. Okay, it's not going to affect any of the steps. All it does, as you see, is instead the very last step, instead of solving for x, we solve for 3x, and then we do one more step and solve for x. We divide by the coefficient of x. If you like math like this, please subscribe to my channel, tell your friends about it, teachers, etc. Leave comments below, and subscribe and continue watching my YouTube channel. Thank you very much.